Assalamualaikum warahmatullahi wabarakatuh. Today, my friend and I would like to share you guys about our mini project ECE354. The title of our mini project is Automatic Door Control. It was prepared by me, Nurul Fatihah Nadia binti Muhammad Khalil, my others friend, Nur Kristina Iwani binti Muhammad Rizwan, and Nazmi bin Amiruddin. So, let's dive into this topic.
Our introduction to mini project is the automatic door control is an effective system that have been designed to automatically open and close the door without using manual operation by switch or push button. We choose switch or push button to act as an input or to give signal to open and close the door, and we choose LED and buzzer to act as an output and indicator when the door is open and closed. Our aim is to improve convenience and user comfort for public places and elderly or disabled users. Application can be used in home, hospital, shopping mall, and factory. Next is circuit design for components that will be used for our mini project, such as for figure 1.1 is a circuit design for buzzer, and next is figure 1.2 is a circuit design for LED, and the last one is figure 1.3 is a circuit design for switch. This is flowchart for our mini project. The system will start by initializing the port for LED, buzzer, push button, and switch. The switch and push button are input for the device, while the LED and buzzer are output for the device. After initialization, the LED and buzzer are in off state. After that, the system will check whether the button is pressed. If the button is not pressed, the LED and buzzer will stay in off condition. If the button is pressed, the LED and buzzer will turn on. And then, the system will check whether the button is still pressed or has been released. If the button is still pressed, the LED and buzzer will stay in on condition. Once the button is released, the system will wait for 2 seconds. After the delay, the LED and buzzer will turn off and the system is ended.
Alright, for our next section is about coding with comments. So in this slide, you can see that there's a diagram picture about our first assembly language. So the above diagram, there's some description about our mini project, which is firstly is about our title project, which is the automatic door control, and some of the lists for the input and output. So here we put our push button. We use our push button, which is only two, PH0 and PH1. Next, for the output, we use buzzer and LED. So how does the assembly language function for this coding is that when someone press the push button, either PH0 or PH1, the LED and buzzer, our output will turn on. Same goes with if the push button is still pressed, the LED and buzzer will be staying turned on. But if either push button PH0 and PH1 is being released after press, the output, which is our LED and buzzer, will have a 2 delay second turn on. Until the 2 second countdown is ended, it will turn off. So that's how our coding system works. Next, we can see in the diagram that we start our assembly language with starting address 1000, and below of the starting address, you can see that there's a setup for the input and output. We declare it which port for the input and which port for the output. In the diagram, you can see that port B is for it acts as the output, which is for the LED. Port T is also the output, which is for the buzzer. And finally, port H is for the input, which is PH0 and PH1 for our mini project. For our next slide, this is the second diagram of our assembly language. So here you can see that there's a three part, which is our main loop assembly language, while press, and delay 2 seconds. So I will try to explain just briefly for each part. So for the first part, main loop, in here we can see that in the diagram, you can see we send a signal in port H, BR set, which also known as 1. We send a number 1 signal to port H, which can also be mean that we are turning on the push button. But since our port H act as a active low, so it does not turn on our switch push button. Instead, it's sending a signal that our push button is not being pressed. Means that 1, also known BR set, is not turning on. 0 is also known as B clear, will turning on the push button. So for this part in main loop, until someone is pressing the push button, the coding will not run for the next program. It will cycling in this main loop. Alright, that's for the first one. Second is on while press assembly language. In here you can see that we are sending a port B signal, which is the LED, the hex FF, which also means turn 1, which is 1 means turn on, and also same goes with the buzzer in here. Okay, below that you can see that we're sending a signal to port H, be clear, which is 0. Since our port H is act as active low, so 0 means the push button is being pressed. So thus, hence the LED and the buzzer will turning on. So below that you can see there's also instruction where we put our 2 second delay, the LDY 4500. Okay, that's for the while press assembly language. And finally, in this diagram, you can see that below the last part, we have delay 2 second assembly language. In here, you can see that we are still sending a signal for port B, which is the LED, to with hex FF means number 1, which is also sending a signal to turn on the LED. Same goes with the buzzer. So for our next slide is our last diagram for our assembly language. So starting here, you can see in the diagram that there is a last function, which is we're sending signal to port B. We are sending hex 00 in port B for the which is the LED. Same goes with the buzzer too. We are sending a signal to port T, be clear, which is 02, means that to turn off the LED and buzzer. This happens after someone is not press the push button anymore. So after in the below, you can see that there's a BRA that goes to the main loop assembly language again. So the function will work again like how it used to. Below the assembly language after the BRA, you can see that there's a subroutine assembly language specifically just for the buzzer tone vibration.
Okay, so for the results part, we are having two parts, which is outside door and inside door. So for the outside door, when we press the push button, the system will stimulate the red LED and the buzzer will sound it. So when both are functioning well, it shows that the door is opening and the person from outside can enter the building. And as for the inside door, the system works exactly the same, which is when we press the push button, the door will open and the red LED will lights up. Also, the buzzer will sound it. So that shows that the person from inside can go to outside. As we can see in the video, when the push button on the right side is pressed, which is for the outside door, the LED will light up and the buzzer will turn on. And also, when we press the push button on the left side, the same thing will happen, which is the red LED will light up and the buzzer will turn on. For discussion part, we faced few challenges when we decided to complete this mini project. So for the first challenge that we face is we need to determine where to insert the 2 seconds delay in our assembly language program so that the door waits 2 seconds before its closing. For the second challenge is we need to make sure that the LED and buzzer are turned on and off simultaneously when the push button are pressed. For the future improvement that we can implement in our project is we can replace simple sensors with fingerprint authentication, or we can use face recognition for a better security. As for conclusion, the automatic door successfully demonstrates the integration of software and hardware application to implement a functional and a reliable system.
That's all from us. Thank you.